Today my talk is to share with you VMware IT's journey on cloud-native container-based applications and how and why and we choose to use PKS and how we deploy PKS. Hopefully our experience can be some help to you. So in terms of agenda, we'll do briefly introductions, which we already did. We'll share the VMware IT's cloud-native journey. We'll talk about the VMware IT's PKS deployment, and then we'll talk about the takeaways. All right. So a little bit about the VMware IT, right? So my group is called the Business IT Group in VMware. Our group is responsible for all of the applications that VMware used to run its business. Right, that including internal intranet, people's HR system, all the way to the portals and the services that customer access. We support all of them. And we have about 400 plus applications in our landscape. We have about 10 million plus lines of code that we written ourselves on top of it. And because VMware is already a 20-year-old, $8 billion company, we have very, very heterogeneous environment with mixed of package of applications. We have package applications, SaaS applications, also custom applications. Pretty much any big name applications you can think of, we have them in one form or another, right? So it is a very diverse portfolio, and we actually manage a lot of things in the group. So one of the key challenges with this heterogeneous environment is making changes become more and more difficult as you bring more and more applications together and integrate them together. And the speed of change become more and more slow. At the same time, the business is asking us to do things faster and as fast as we can possibly can and as cheap as possibly we can. And to meet those challenges, we went on this journey to start looking at how do we develop our applications, right? How do we make changes to the package applications, and what are the best way to achieve the velocity and agility that business is looking for? So our journey truly started towards the end of 2014 when we first started looking at a container. At that time, Docker has just become popular, right? Our initial motivation of looking at Docker is quite simple actually, because in our traditional process, we hand off our developed code to operations, right? We do those, once a month release parties. Everybody come on Friday, right? Sit together doing the release. The release can last from 12 hours to 24 hours, depends on what's happening, right? The biggest challenge we find in that process is the handoff between dev to ops, right? Developer does write release notes, but developer are lazy people. So I come from developer, I'm lazy too, so I don't like to write those things. Our op friends are busy, right? They have to run systems, they have to monitor systems, they have to fix system that broke, they have to release the new things. So they don't have time to read the release notes either. So what you're showing is on the weekend, everybody shows up Friday night, then everybody start pointing finger at each other, right? Right? You didn't read my document, you didn't write it in the document. So so there must be a better way of doing that. And then when we look at the Docker, we said this seemed to make sense, right? Instead of writing my release notes, I write everything to the Docker containers. I hand that off to the operations. Operations only have one way to dealing with whatever the container somebody hand to it, just to make it run. It's great. So let's start. We pick a simple, LAMP-based blog system, put that into container, and try that out. And both developer and ops guys loves it because they simplify the handover, right? You just give them a container to run it. And we actually push that container all the way to production. Then we showed our learnings and present our findings to our executives. It's just like any other good executives like to challenge their team, right? The next thing our executive asked us to do is to go find the most complex, most difficult applications, try to containerize that. So we said, okay, let's go do that. So in beginning of 2015, we started on that journey. The application we pick is our customer support portal, the portal that serves all VMware customers' needs after the sales. And as you can imagine with our heterogeneous environment, that application pretty much have a tentacle into 60% of the application on the back that running the company in one form or another. So we start from the beginning of the web layer and going layer by layer down, right? We try to package them into container. Web layer is easy. App layer is a little bit difficult, but by the time we get to the integration layer, We are looking at about 36 different images. If you will run them at a full scale, that's about 250 containers. And manually running them is just not an option. Right? Ops guy look at it, I'm not going to run 250 containers by hand. So, and we also learned that because those legacy applications require, for example, clustering, shared sessions, right, replications, all of that things, that Docker and the container doesn't natively make it conducive to do. It's very, very difficult, and there's a lot of manual step you have to do to make it work. At the end, the efficiency gain from legacy application really doesn't warrant the effort that goes into try to show home those into containers. So we decided to abandon the shift and lift approach to those complex applications because it's just not the worst effort, to be honest. So, but we do realize the value of containers. We do allow the team that does greenfield application development to continue to use containers, and we'll continue to run them on VMs. And we sourced a third-party tool to actually orchestrate small sets of containers together. And that actually worked out quite well, because the reason at that time Docker Compose is not a thing, Kubernetes is not a thing. They're really not whole, very open, standard-based orchestration framework for containers. So that's why we did that way. And when it comes to 2016, we really look at our journey, really look at our priority, look at where we are. We said we should not be abandoning the journey because we need to make changes. And we decided to move forward by actually adopting cloud-native applications and start developing applications truly in the microservice fashions. And for those legacy applications, we decided to leave them alone for the time being. And when we master the skill of developing the microservices, we will refactor them into microservices and make them run in containers. And as we're building out those things, we still haven't solved the platform problem, right? How do we get those containers to run in an orchestrated way? And in 2016, when we look at the market, we couldn't find a mature tool that deals with Docker containers. But we do find that the Pivotal Cloud Foundries give us a quite good platform to run those containers. And the reason is because we're primary Java shops, right? Most of our applications developed in Java using Spring frameworks. And Pivotal Cloud Foundry seemed to be a logical place to run that. And that's why we did a Pivotal Dojo with Pivotal and deployed the Cloud Foundry and get the team running on the platform. And in 2017, we rolled the platform out to a much larger team. Right now, between non-production to production environment, we have about 2,000, 2,500 containers running that platform with all kinds of microservices that serve both internal, external, and the partner integration needs. But as we go through this journey, Pivotal Cloud Foundry is great, right? It does solve a problem. But it also introduces a different set of problems because Pivotal Cloud Foundry is a very opinionated platform. You have to do things exactly the way it is. If your application is slightly wonky and different that cannot be fit neatly into that, then to shoehorn it into it is actually quite a difficult task to do. And the second part is, even though Cloud Foundry give us this very nice service broker, Bosch managed service construct, the availability of a service is a challenge on the platform to make them available. And the package ourselves, the systems into services, is quite difficult too. We did package one is a MariaDB cross data center cluster, but just package that service took us 3 months, right, to make it work consistently, solidly. And we're not gonna embark on doing that for every single possible data and service that we're gonna use because it's just not a viable option to do that. And also, as we move to refactor the legacy applications, there are certain legacy applications that require access to, for example, storages, right? So shared storages. There are applications that require access to the actual file systems and all that stuff, which Pivotal is not be able to do. So we need to look at alternatives, right? That's when we start. And the good thing is in 2018, Kubernetes really takes off, right? It's basically now is the de facto orchestration platform for containers. And once we look at the Kubernetes, it does solve majority of problem we have with PCF and allow us to basically move a lot of those workload that doesn't fit natively into PCF into Kubernetes, into containers. But as we look at the Kubernetes, it does introduce its own overhead, right? As we're coming from the Bosch managed Pivotal Cloud Foundry world, right? Manually rolling and manage a Kubernetes cluster, it just seemed to be way too complicated. There are too many moving pieces, and they have to be manually orchestrated in a consistent way. We did set up those plain vanilla Kubernetes cluster ourselves. It took a while, and there's a lot of trial and errors in it, and make it running a large scale is quite difficult, to be honest. And also, and that's why we start looking at. That's why we didn't go with that and start looking if there's a better alternatives. And that's when the Pivotal Container Service become a officially declared product. And we look at the feature it provides. It does fit into our ecosystem nicely, and it gives us a lot of things that we're looking for. So what are we looking for from a Kubernetes offering, right? So Kubernetes take care of the containers, right? Who's taking off the Kubernetes, right? In the Cloud Foundry world, PCF take care of the containers, and the Bosch take care of the Cloud Foundry itself. And it provides a very neat day one, day two, provisioning and operation model that is very consistent and very easy for people to understand and practice, right? We would like to have the same kind of operation model for Kubernetes as well. And from a network topology perspective, because VMware IT is a very heterogeneous environment, we need a network plane that not just native to the containers, but it can stretch across legacy applications, to traditional workload as well. And traditionally, what you do is you use netting, right? From the container to the host, then from the to the physical network. The challenge with that is you have obscured the container workload, container traffics. You cannot really tell if the traffic is coming from the container, which container, when you look at it from host. And apply the network policy at that level become very difficult, and manage it become very tedious, right? And also, from a storage perspective, we needed to be able to support persistent volumes into the containers, right? And we don't want a bandaged solutions. We want a storage solution that is consistent with our storage policies and the way we provision and run storages in our ecosystem. And also, we want to make sure that we take security into consideration, right? We want a way to be able to put a policy driven what container developer can push into the systems, right? We don't want any developer to be able to pull a random container off the internet and run it, because that is a security risk, right? And also, we want to make sure that operationally it fits neatly into our support infrastructure. For example, how we monitor our systems, how we do logging. We want to make sure Kubernetes can fit into that neatly. And last but not least, we want to make sure that our developer can get access to Kubernetes through a self-service capabilities, because we don't want to be there handling tickets and answering phone calls, or see it if somebody sends you a Slack request for a cluster, right? So that's where PKS solves a lot of these things that we're looking for, and it solves a lot of those problems. So this is basically the PKS architecture. It's basically sits on top of our vSphere-based infrastructure with NSX-T as a network layer. On top of that sits the Bosch managed Kubernetes cluster, and also it's integrated with Harbor is VMware's open source image registry, which I think they just get accepted into Cloud Native Computing Foundation as a official project for Kubernetes. And also, along with that, it provides a lot of the out-of-the-box integration with a lot of tools that we use. For example, we use VROps to monitor the infrastructure, right? We use Wavefront, and we use LogInsight for monitor our applications, and it fits neatly into that. So, talk about how NSX-T truly help us, right? Basically, our deployment are slated into this diagram. We have separate networks, subnets for our management network for the whole infrastructure, and then the administration network for the Kubernetes itself. And each Kubernetes cluster itself that gets provisioned gets its own subnet as well. And they are networkly segregated so that we can ensure that unauthorized access cannot go across and in between of the pods, in between of the cluster. And also, we can ensure that the workload cannot get access to the administration network and the management network. From ingress-egress perspective, we use the NSX Edge, which serves as an ingressing point and also as a load balancer. And also, actually, it's a load balancer, ingress point, and a firewall all in one. Right? We can define firewall policy at that level as well. And one of the neat feature in the PKS with NSX-T integration is when we push a cluster set workload into Kubernetes, right? There is a NSX-T load balancer, virtual load balancer automatically created for that workload. And it keeps track of the workload so that we don't have to manage the load balancing separately from network perspective. And also in the NSX-T landscape, every pod actually get a real IP address that is visible to the network, so that when we define firewall policies, we can truly see which container is talking to which container, what container have access to what. We can actually define firewall policy to that level of granularity that can control the traffic to that way. From a storage perspective, we are a heavy user of VSAN. So VSAN gives us a way to virtualize the storage, allow us to provide the different tiers and policy-driven storage provisioning. And in our PKS deployment, we use the local drive with combination with the network attached storage as well. Depends on what data the user, what kind of performance characteristic the user look for. VSAN will intelligently pick the right storage to service that. Right. On top of that, we integrate the PKS product actually integrate the open source Halchway project, which provide a storage plugin into the underlying physical infrastructure, which allow us to be able to do things like a persistent volume. So in the PKS world, when we declare persistent volume attached to a container, that persistent volume actually created as a VMDK file on the storage. So from operation perspective, these files, even though they are persistent volumes, they are no different from any other VMDK files that they already manage today. So their backup, restore, and all that existing capability can be leveraged looking at the VMDK file, and we can specify policy to those persistent volume in terms of what kind of backup restore needs to be applied, or what kind of performance they need to guarantee, and all that can be managed in a centralized way. And we also use Harbor heavily. The reason we use Harbor, not the open Docker registry, is one is because it's integrated, right? Second part is Harbor provide RBAC-based access control, which the open source Docker registry doesn't have. And when in an enterprise, you really need that. Right? You need to make sure the right people have access to update and change the right Docker images and pod scripts in the registry. And also, Harbor integrated with Notary and Clary, which give us a way to politically define what can be run into our clusters. So in our build pipelines, we use Clary to scan the images to make sure there's no vulnerability in it. And then we use Notary to sign the image. And our Kubernetes cluster configured to not run any container that's not signed by the registry. Right? That's how we control what is allowed to be run. And in VMware IT, we create our own golden base images based on the public golden images, and we harden them and add the VMware mandated daemons and the agent process into it, and then we build from the rest of it. And we make sure that every image that we run in our cluster is built based on that, so that we can ensure the security and the integrity of the containers from that perspective. And from operation perspective, in VMware, we are a heavy user of log insight, which provide log ingestions and log analytics and alerting, reporting, all of that for us. And PKS out of the box integrated with log insight. But it can be fairly easily integrated into any logging system that supports sysd, syslog endpoint and all of that, because internally they utilize the FluentD for that. So all the log shipping is done through FluentD, and those get pushed to whatever the logging system that you choose. In our case, we choose login site because we use that to monitor the rest of our infrastructure as well, so that it will fit neatly and allow us to be able to look at the log from end to end, right? Because today, majority of our workload still runs in the legacy stack, which still is not fully integrated into the containers, right? And also automatically it populates things like cluster tag IDs, pod IDs, namespace IDs, so to make it very easy to look at the log and figure out where the problem come from. And from monitoring perspective, Kubernetes out-of-box basically use the Hepster and the Telegraph, and we use that to push to Wavefront using Wavefront proxy that is integrated into PKS. And the Wavefront provide a very, very good out-of-box Kubernetes monitoring dashboard, which pretty much give you 360-degree view of your Kubernetes deployment. Right, and the reason we use Wavefront is because we use Wavefront to monitor our PCF platform as well, and we use Wavefront to monitor our application as well. So all the metrics from our whole ecosystem actually go in there. So the benefit of having a single monitoring tool where all these things go together is make sure it's easier to troubleshoot, to correlate the stats and the data points for you to be able to look at the trends and look at the system behaviors much easier from that perspective. And we actually deploy our platform in 2 different data centers in an active fashion. The reason we do it this way is because we want to provide higher availabilities to our developers. Basically, we're saying is in each data center, we only guarantee 99 to 99.5% availabilities from infrastructure perspective. But with this setup, we expect that application be able to achieve 4.9 to 5.9 availabilities. But application bear the responsibility to bridge the last miles by correctly routing their traffics, correctly monitoring themselves, correctly sending the signals to the infrastructure that they're in trouble, so the infrastructure can help them doing the automatic failovers and reroute traffics to different data centers. Okay, so takeaways. So why is the Pivotal Container Service different from other plain vanilla Kubernetes cluster, and why is it good for enterprise to use that? One is that PKS are committed to provide a constant mainline compatibilities. What that means is you will get the latest feature that Kubernetes brings on board in no more than 30 days, right? And the second part is that automated provisioning, scaling, and patching through BOSH is very, very valuable from operation perspective. Give your operation team a peace of mind that whenever they run the deployment, it will be consistent, it will be repeatable, and all these best practice from operation perspective is already ingrained into the BOSH itself, so that you don't have to reinvent them, right? The NSX-T integration obviously simplified the network and traffic management greatly, and allow us to create a much more flat and secure network to provide provide application access to all the components that need access to, right? From storage perspective, VSAN give us a storage solution that can work across both container workload and traditional workload, give us much more efficiency and better utilization of our storages. And on top of that, it shipped with Harbor, which give you a secure image store that you can manage your image blueprints very securely and deploy them securely, right? And out-of-box integration with login site and Wavefront just icing on the cake to make your operation even better. So that's the title of this talk is have your cake and eat it, right? All right, I think that's all I get to talk about, and there's 5 minutes left. If you have any questions, feel free. Yeah.
VMware and Pivotal are both part of the Dell now.
Mm-hmm.
Did that influence your decision to use PKS at all, or was it strictly based on the
I would say it's about 80-20. So yes, we work for we all are part of the Dell family. But you will be surprised how many competitions there between VMware and the Pivotal. So we are being encouraged to explore the products from our sister companies, but we're not being mandated to use it, right? And these are, I would say, Pivotal or Dell are the first place we go look for solutions, but the solution has to meet our requirement and fit into VMware's ecosystem, actually ultimately benefit VMware. If it doesn't, it's not helping, because you look at this way, I'm a VMware stockholder, I'm not a Pivotal stockholder, right? Make Pivotal stock go up is not helping me, right? So from that perspective, I would say, yeah, so we do evaluate them in a common scale with other solutions. So for example, right now, we have a very big conversation with Pivotal going on, because Pivotal Cloud Foundry serves as well, but the cost of is ridiculous. It's very, very expensive. And the bigger, it helps you go fast, go big, but the faster you go, the bigger you go, the price tag just goes up with it, right? So we are having these conversations. If the cost is not going to benefit the VMware, we'll get rid of it and go back to Kubernetes. All right. Any other questions? Yeah. So to be honest, I have some of those conversations with Pivotal guys, right? But I don't have a complete preview of what their plans are. But if you ask me what my view is, I think what Pivotal, not just Pivotal, Cloud Foundry should do is porting that experience over onto Kubernetes. Basically replace Diego with Kubernetes, and all the rest of the the Go routers, the service brokers, and you actually see that happening, right? You look at the cloud native compute foundations, they start adopting, service brokers, build packs, all these constructs that are introduced by Cloud Foundry into this. So I wouldn't be surprised in a year and a half, 2 years from now, Cloud Foundry is just going to be an experience layer that deploy on top of the Kubernetes, just like SDO is, right? So that's how I think it will happen. It may or may not, I don't know, but it will take some time, because there's still some unique capabilities like Diego and all of that provides that I think they're waiting on Kubernetes to catch up from that perspective. But this is my view. Any other questions? Yeah. Mm-hmm.
And there's multiple capabilities that are in the pipeline. Is that a direct result of the work that you're doing? Saying you're trying to deploy, run applications, and say, hey, you invest in this way?
A lot. So one of the biggest mission of VMware IT, besides keep the company running, keep making money, is to be the customer zero for all our product. So that started about 3-4 years ago. What happens is, generally when a product gets to a beta stage, VMware IT gets a bit of it. And we start running experimenting workload on it. And generally we are in production with the actual product about 2 months before it becomes GA. And we actually run our real production workload on it. The reason we do that is because we want to validate our product in a real world scenarios. And our assumption is that if that product works for VMware IT, it probably works for 95% of the company and customer on the planet, right? Because VMware is very typical of your large enterprise, right? So that's how we do that. And in the case of PKS, we are actually very, very early adopt. We are starting a conversation while the product is just in concept, right? We got the first bid and we start running it. A lot of the things that you see in the latest 1.2 releases is directly come from the work that we're doing, the part that we are asking them that missing for us. Yep. Yep.
You mentioned earlier that after you did a POC, you tried to containerize some legacy applications and had to abandon it because of cost. Can you talk a little bit more about what was the
Oh, sure. Yeah, it's a very, very interesting challenges, right? So our legacy applications, your traditional multi-tier application, you have web tier, application tier, integration tier, you have your database, you have your ERP system, you have your whatever the package application that underneath it that sits there, right? So a couple of challenges in it. One is our legacy application runs in things like Tomcat, WebLogics, and they rely on clustering capability of those systems, right? Those clustering depends on multicastings and network construct, which the container don't natively give you, right? Once you put them into container, you literally cut that out, right? So is there a solution to that? Yes, there is. But that requires me to make changes to the legacy applications, right? So I can externalize all these sessions to external part, but then that's external dependency I have to introduce. That's another set of container I have to manage, right? And the other thing is that in our workload, because the way they're integrated, the biggest challenge is they have dependencies. One service cannot come up until the other one has came up, right? And that dependencies start with a simple A to B, gradually become a mishmash of spaghettis, of startup sequences, right? And to orchestrate that startup sequence in a container world is very, very difficult, right? As far as I know, even today, the only way we can do that is manually. There's no reliable way. And the way we solve that is by writing custom script in the dependent container to the container depend on. So the script, when the container first starts, the script does is to ping the other containers, see if it's up or not. Unless that one's up, it will now try to start itself. But one is, that is very, very custom and proprietary. Second is not very reliable, right? There's a lot of those challenges you will find as you go take on more bigger scale complex legacy applications. If you have your traditional simple legacy application like like the sample they always like to give, right? You have a Apache server with a Tomcat server with a MySQL database underneath it. No problem. It's easy, right? You can just stick that into a pod or stick that into the compose file. It'll work just fine. But if your application involves certain degree of complexities, it becomes very, very challenging from that perspective. No, it doesn't. No, it doesn't. So that's why we didn't try to shift lift those applications. We said we'll leave them where they are. And the approach to them is we already started on the effort is basically what I call the choke and release. Basically what we do is we take a component of the legacy applications, right? We first rewrite the interface. So we take the component of, we take a piece of the legacy application as a module. We rewrite it into microservices, right? Then what we do is we take that module that's still inside the legacy, we take out all the backend code, we replace that with proxy to the microservices. And then we go to that slice. It's like a pizza slicing. Right? You do slice by slice by slice. Eventually, our hope is that we slice enough, there's nothing left there. Yep. Yeah, into microservice with a managed dependencies. Yeah, with clear control dependencies. Yeah, so all these nice things said about the containers, all of that. End of the day, what you realize is your agility comes with how you manage your dependencies, right? You have to be very thoughtful for what dependency you pick, right? What dependency you want to have, what dependency you don't want to have. All right? I think that's it. Thank you.